Our second lesson this week is going to be about rounding decimal numbers to the nearest whole number. And this we can use the skills that we've used before. So we'll look at what those are and how they relate to what we can do in decimal numbers. What also we need to think about is what a whole number is and another word that people might use for it. So first thing I want you to try and do is try and remember our way of rounding numbers. I'll go through it with you afterwards. But what I want you to try and do is to round this number 3,278 to the nearest 100. And think about what our rules are on our way of doing it. And then I'll come back to how that helps. Have a go now, and then I'll explain it in a minute. The question was to round 3,278 to the nearest 100. So the first thing we need to do is think about what numbers are going to be involved in this and what we can take away straight away from that. So firstly, where's our number that the column we're looking to round into? And that's into the hundreds column. Now, the number that's going to tell us that is always going to be the number in the column 1 lower than it. So in this case, it's going to be these 7 tens going to tell us which way we go. The next thing we want to do is think about what numbers they're in between. So what numbers are above 278? What's the 100 above 278? What's the 100 below 278? The 100 above it is 300, and the 100 below it is 200. This is a common mistake that people sometimes make, that when you round down, you go down. But if you look here, actually, when you round down or are going down, it's the same as what's currently in there. So you can think about this in a few different ways. You can think about when I'm rounding up, I'm changing the digit by 1. When I'm rounding down, I leave it as is, just as a quick note. Then we look here at our 7 tenths and we say whether or not 7 tenths is closer to 100 or whether it is closer to no hundreds. Now there's a general rule we can use here, but the way in which we look at it is if the digit is 5 or more, we can go up. If it is 4 or less, we can go down. So looking at that, we can say 7, that's 5 or more. That means it's going to go up. It means it's going to go to 300. We pull down any number above our target column, and then whatever number we've said is closest to, making sure all numbers after the target column are zeroed out like this. That's the way that we do it with numbers which aren't decimals. We're going to later on see if it's the same for numbers that are decimals. Okay, so what we're now going to look at is when we're looking at decimals, we are talking about rounding to the nearest whole number. So we're going to think about what a whole number is and if there's another word for that. So over on the side here, I've got which 2 whole numbers are these decimals in between. You can pause now and have a go and see whether or not you can do that. So we're looking on our number line here and we're looking for the 2 whole numbers that are either side of the digits we have down. Now this just involves counting, hopefully, but what you're looking at here is thinking about what whole numbers, and whole numbers are any number that doesn't have a decimal associated with it. So what numbers are either side here of our number line? So when we're coming down to the bottom here, each time if we have a look, we're adding 1 tenth. We're going from 1 tenth to 2 tenths to 3 tenths to 4 tenths to 5 tenths to 6 tenths to 7 tenths to 8 tenths to 9 tenths. This would be 10 tenths, which means actually I'm adding 1 to the units, the ones column, which makes that 8 into a 9. And vice versa this way, if I'm taking away 1 tenth, then it would be 8.0. Because 0 isn't a significant number, we don't have to show it. We can just show it as an 8. Our 2 whole numbers, therefore, are 8 and 9. These are also referred to as integers. So if you ever get asked to round a decimal number to the nearest integer, integer just means whole number. and that means without a decimal spot place. Let's have a look at how that can help us when we're trying to round a number. So the first thing we've got down here is our next question. I want you to have a go and see what you can do, thinking about how we've talked about finding those whole numbers to begin with. Pause it now and have a go. So let's find the whole numbers first. And it says here 5.3 lies between the whole numbers something and something. Now we can just add those in, much as we've done before. And what we're looking at here, you can see there's an increase in 1/10 each time. So the number that's above here, we increase the 5 by 1 to make it 6. And we are removing this 1 to a 0. 0 isn't significant. We don't need to write it. We can just write 5. So the two numbers it's between is 5 and 6. Now I want to just for a moment take you back to what we said before when we were looking at the common error people make when they round and they round down to the number below it. What you're doing here is you're looking at whether or not what numbers before it and after it. And the same with our hundreds. The number we're going down to is the ones we've already got, if you look, whereas the number we're going up to is one more. So remember that, makes your life easier. The next thing it asks is it closer to, and remember we're rounding to whole numbers, so we're looking at which two whole numbers it's in between. Is it closer to 5 than to 6? It is closer to 5 than to 6. We can see that because our midpoint is here at 5, which we said is always our split. 5 or more we go up, 4 or less we go down. We are going down to 5. So 5, it is closer to 5. We can see it here than 6. So we are going to take that number down to 5. So that means 5.3 rounds to 5 when it is rounded to the nearest whole number. So how does that link back to our rules when we're thinking about rounding to the nearest number? Is it any similar to what we've done before? Let's have a look. We'll take the example of 5.3. So our number is 5.3. And it says round to the nearest whole number, which means any number which is after the decimal point. And actually what that always means whenever you're rounding out decimals is to the nearest ones. So we're rounding into this column. Now, the next number will tell us what we're doing. So here it is. This looks very similar to what we've done before. We have to think about what's above it and below this one. So we know if we're rounding up, we'd be going to 6. If we're rounding down from 5.3, we're going to a 5. Remember your number line. Remember what we said before. This is the same as the digit that's already in there. This is one more. Then we look at our rule of 5 or more, we go up. 4 or less, we go down. This is 4 or less, so we go down. So rounding this to the nearest whole number, the answer is 5. So you can see actually the method is identical whether we use a number line or whether we use our method. Either way works. And it doesn't matter whether this is a really long number. Let's have a look and see. Making up a number, if we think about 465.3927, really long, massive number. But remember, when we're rounding to the nearest whole number, we only care about the ones column and the column 1 below it, our 10th column. We don't have to think about the rest of this. This is going to be pulled down and is going to become part of our answer, and we don't change it. We look into this. This is 5.3. We know that this either goes down to a 5 or up to a 6. We know it goes down because 3 is 4 or less. Put that 5 in there, and we get rid of all of those. They all become 0, therefore non-significant. We don't even have to write them down. Our answer is 465. So no matter the number, this principle will work and actually sets us in good stead for later on. So here are our questions for today's lesson. Try and go through it using the ideas we've gone. You can use any method you like. You can use a number line to solve them. You can use our method if you find it easier, and try your best. Post your answers to Tapestry, and remember, keep trying your times tables with stars. Thank you, and we'll see you in the next lesson.